Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What is data mining? Data mining refers to the process of extracting valuable insights, patterns, and knowledge from large data sets. It involves using various statistical and machine learning techniques to discover hidden patterns, relationships, and trends within the data, which can then be used for making informed business decisions or generating predictive models. Data mining encompasses several steps and techniques, including 1. Data preparation. This step involves gathering and pre-processing the data to ensure its quality and suitability for analysis. It includes tasks such as data cleaning, integration, transformation, and feature selection. 2. Data exploration. In this step, analysts explore and visualize the data to gain a better understanding of its characteristics, distribution, and relationships. Exploratory data analysis techniques are used to uncover initial insights and identify potential patterns. 3. Data modeling. In this phase, various data mining algorithms and techniques are applied to the prepared data to build predictive or descriptive models. Common data mining techniques include classification, regression, clustering, association rule mining, and sequential pattern mining. 4. Model evaluation. After building the models, they are evaluated using appropriate evaluation metrics to assess their performance and validity. This helps determine the accuracy, reliability, and usefulness of the models. 5. Knowledge discovery. The final step involves interpreting and extracting meaningful knowledge and insights from the models and results obtained. This knowledge can be used to make data-driven decisions, develop strategies, or generate actionable insights for the organization. 2. What is RDBMS? Explain its features. RDBMS stands for Relational Database Management System. It is a software system that is designed to manage relational databases, which are based on the relational model of data. RDBMS is widely used in various applications and industries due to its efficiency, flexibility, and ease of use. Key features of RDBMS. 1. Tabular structure. RDBMS organizes data in the form of tables, where data is stored in rows and columns. Each table represents an entity or relationship, and columns represent attributes or properties of the entity. 2. Data integrity. RDBMS enforces data integrity by implementing various constraints such as primary key, foreign key, unique key, and check constraints. These constraints ensure data accuracy, uniqueness, and validity, preventing inconsistencies or errors in the data. 3. Relationships. RDBMS allows the establishment of relationships between tables using primary key foreign key associations. Relationships such as one-to-one, one-to-many, and many-to-many can be defined, enabling data integrity and efficient data retrieval through join operations. 4. Query language. RDBMS provides a structured query language SQL for interacting with the database. SQL allows users to perform various operations, such as querying, updating, inserting, and deleting data from the database. It provides a standardized way to retrieve and manipulate data. 5. Data security. RDBMS offers robust security features to protect the data. It supports user authentication, access control, and data encryption mechanisms to ensure that only authorized users can access and modify the data. It also allows for implementing data backup and recovery strategies to prevent data loss. 6. Transaction management. RDBMS supports transaction management to ensure data consistency and integrity. Transactions represent a sequence of database operations that must be executed as a single, atomic unit. RDBMS provides features like asset properties atomicity, consistency, isolation, durability, transaction logging, and rollback mechanisms to handle concurrent access and maintain data consistency. 7. Scalability and performance. RDBMS is designed to handle large amounts of data and support concurrent access by multiple users. It provides indexing, query optimization, and caching techniques to improve query performance and response times. RDBMS can scale vertically, increasing hardware resources, or horizontally distributed database to accommodate growing data and user requirements. 8. Data independence. RDBMS offers data independence, separating the logical schema database structure from the physical storage details. This allows for easier maintenance and modification of the database structure without affecting the application programs or queries that access the data. 3. What is an entity relationship diagram? An entity relationship or diagram is a visual representation of the entity's objects and their relationships in a database. It is a conceptual modeling technique used to design and illustrate the structure of a database system. Diagrams are primarily used in the early stages of database design to help developers and stakeholders understand the data requirements and relationships. Key components of an diagram. 1. Entity. Entity represents a real-world object, concept, or thing that can be uniquely identified and stored in the database. Entities are typically represented as rectangles in a diagram and labeled with a descriptive name. 2. Attribute. An attribute is a characteristic or property of an entity. It provides additional details or information about the entity. Attributes are represented as ovals or ellipses connected to the respective entity. 3. Relationship. A relationship represents an association or connection between two or more entities. It describes how the entities are related to each other and defines the nature of their interaction. Relationships are represented as diamond-shaped connectors between entities, with labels indicating the type of relationship, e.g., one-to-one, one-to-many, many-to-many. 4. Cardinality. Cardinality specifies the number of occurrences or instances of one entity that are associated with another entity in a relationship. It helps define the multiplicity or participation constraints between entities. Cardinality is often represented using symbols such as 1, and many, or 0. 1 optional. 5. Primary key. A primary key is a unique identifier for an entity within a database. It uniquely identifies each record in the entity and ensures data integrity and uniqueness. In a diagram, a primary key is indicated by underlining the attributes representing the primary key. 6. Foreign key. A foreign key is a reference to the primary key of another entity. It establishes a relationship between two entities and ensures data integrity and referential integrity. In a diagram, a foreign key is indicated by a dashed line connecting the attribute representing the foreign key to the primary key it references. 4. Define referential integrity. Referential integrity is a concept in database management that ensures the consistency and accuracy of relationships between tables through the use of constraints. It defines and enforces rules that govern the relationships between foreign keys and primary keys in different tables. Referential integrity is based on the principle that every foreign key value in one table must have a corresponding primary key value in another table. It ensures that relationships between tables are maintained correctly, preventing orphaned or inconsistent data. 5. Define alternate key. An alternate key, also known as a candidate key, is a column or combination of columns in a database table that can uniquely identify a record within the table. Like a primary key, an alternate key ensures data integrity and uniqueness, but unlike a primary key, there can be multiple alternate keys within a table. 6. Define constraints. Constraints in a database are rules or conditions that are applied to the data within a table to maintain data integrity, accuracy, and consistency. They define certain limitations or requirements that the data must adhere to, ensuring the validity and reliability of the database. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.